Alright, suppose you were given the task of finding the z-score for this distribution, one IQ distribution. And they tell you IQ distribution has a mean of 100 and a standard deviation of 15. And they ask you to find the z-score for, let's say, IQ of 130. So we want to find the z-score for our IQ of 130. Well, that's our value of interest. So 130. Well, the formula that you would find in the book and that we've talked about before is z equals x minus mu over sigma, and that's for populations. If it's for samples, it's x minus x bar over s. But either one basically means the same thing. You're taking the difference between the value of interest and the mean and dividing it by sigma. Well, if I am looking for 130, I'm going to take 130, subtract 100, and divide it by 15. And what do I get? I get 30 over 15, which is 2. And that makes sense because if we look back at what a z-score represents, it's how many standard deviations a given value is away from the mean. That's what the z-score represents. How many standard deviations a given value is away from the mean. So IQs are normally distributed, so it's okay that I'm using this bell curve here. You can't say that about everything, but IQs are. So I'm going to put a 100 right here because that is the mean. Whenever something is normally distributed, the mean, the median, the mode, they're all right in the center. So 100 is the mean. That's right there. When they tell me that the standard deviation is 15, that means one standard deviation away, mu plus sigma, is 115. Two standard deviations is 130. That makes sense because 130 was my value of interest, and when I found z, it came out to 2. Why? Because 130 is 2 standard deviations away. So that's what a z-score is. It's a measure of how far away a particular value is from the mean using the ruler of standard deviations. So we're not going to measure in inches, we're not going to measure in IQ points, we're going to measure in standard deviations. And that's what a z-score is. And obviously it has some uses that should already be apparent to you, because this is all information here that we learned about when we talked about the empirical rule. So we can say that if you have an IQ of 130, that you are smarter than, let's see, you got 50% here, and you got another 34.1 plus 13.6 is 47.7% there. So if you have an IQ of 130, you're smarter than or as smart as 97.7% of the country. Or not the country, whatever, of people in general. So that's it. In a normal distribution, the area under the curve is 100%, or 1.000. So what we just found here is that the p of x less than or equal to 130, which is the equivalent of the probability of finding a z-score that is less than or equal to 2, is 97.7%. But I'm going to write it as, not as a percent, because I have to put percent here if I do that. I'm going to write it as a decimal. So that's what I found out just from right there, just from the empirical rule. If you have an IQ of 115, you're still smarter than this 50%, plus another 34%, which makes you smarter than or as smart as 84.1% of the country. Okay? If your IQ, I should actually say, if your IQ is higher than 115, then you're smarter than 84.1% of the country. Okay? At least. So, this is all well and good if you have an IQ that is 1 standard deviation, 2 standard deviations, 3 standard deviations away from the mean in either direction. Because if that is the case, then you can use the empirical rule to figure out that kind of information. However, suppose you're not. Most people aren't exactly at those values. Suppose you have an IQ of, say, 120. You're certainly above average, but how above average are you? Well, if you do that and you subtract and then divide, you'll get 4/3, which is 1.33. So 1.33, here's one standard deviation. Let me switch charts for a second. So if we're 1.3 standard deviations, here's one standard deviation, there's two. So I'm about a third of the way there. I'm not about a third, I am a third of the way there. Okay, so this is 120. This is 100. We want to know what percent of values are to the left of that. It's a valid question. You want to know, where do you rank? You could also answer what percent of values is to the right of that. And we'll answer this one first. Okay, so how do I do that? Well, the answer is you can use any calculator that does normal distributions if you know how to input the values. You want to find the probability of z values less than or equal to 120. Oh, not 120, that's not a z value, right? That was an x value. The z value was 1.33. If I have a calculator like I do in Alex, I would just fill in a 1.33 there and it would tell me the area, the shaded region. And it would always be a number between 0 and 1.00. Between 0% and 100%. And we know it should be greater than 50%. We're going to figure out what it is. How? We're going to go down here. I don't have the Alex calculator right here. Let me erase this work from earlier. I have a table. This table is found on pages 644 and 645 in your book. 644 relates to negative z values, so if you're below average, which is sometimes a good thing if we're talking about blood pressure, right? If you're below average blood pressure, that's good. If you're above average, you'll use 645, page 645. So table E in your book. It's also on the front cover, and it's also in a pullout. Notice in either one, the area that is shaded is to the left of the z value. It's to the left. It's to the left. Of course, now the z value is to the right of the mean. Okay, because now we have z's that are greater than 0 over here, while we have z's that are less than 0 over here. Anyways, I've already copied and pasted that into here, and now I'm going to use it to find out my probability of z less than or equal to 1.33. To do that, I'm going to find 1.3, which is down here, and I'm going to look across. But it's not 1.30, so I don't look in the first column. It's not 1.31, so I don't look in the second. I look in the third column because it's 1.33. It's a weird way, but the second decimal, you look up here. The first decimal place, you look up over here. The first two, actually, 1.3. Okay, so I find the 1.3, and then I find the 0.3. 1.3 plus 0.03 is 1.33. And so I'm going to look in that column all the way down here, and you can see where they overlap. That's my answer, 0.982. So if you have an IQ of 120, you're doing pretty good. So you're in the top 10%. And that's how you use z-scores, and they're found, you see them in economics, you see them in finance, you see them in psychology, biology. They're used all over the place, all different fields. So we're done, and I hope that helps explain a little bit. We'll do some more problems later. Stop.